Thanks for tuning in to the Lean 911 podcast, where you'll have a voice directly from the Gemba. I will rely on my 3 decades of Lean successes as well as my failures to answer your most challenging questions regarding your Lean transformation. I'm your host, Mark DeLuzio, President and CEO of Lean Horizons Consulting and the Principal Architect of the Danaher Business System. Looking forward to your questions. Now, let's go to the Gemba. Hi, Mark DeLuzio here with another episode of Lean 911. And this is part 6 of a now 6-part series on problem solving. And I can guarantee you there'll be more problem solving down the line because it's a vast subject. And, you know, as I think I said earlier in one of the earlier podcasts, Lean, at the end of the day, is all about problem solving. And I'll bring back something I learned at Toyota, my first visit in Japan of many, to Japanese companies and Toyota and their suppliers. In 1990, an executive said the difference between a world-class company and one that's not is their ability to solve problems. At Toyota, the great Toyota, he says, we have problems too, but we only solve our problems once, which basically means he doesn't fix the problem. They solve the problem. And I have an episode on that earlier on. I forget which one that was, but if you go to lean911.com website, you'll find all the episodes in there. This is episode 23, and I initially was going to have a 5-part problem solving series, and I thought about one more aspect of problem solving I wanted to bring to you. And like I said, I'm sure there will be many more going forward. But this one's called Trust But Verify. Challenge the status quo. And by the way, Trust But Verify was something I adopted from Ronald Reagan. For those of you who are old enough to remember who he was, when he was asked, do you trust the Soviet Union? He says, yes, I trust them, but I verify. Trust but verify. Okay. And that is something I want to bring to the forefront in problem solving, because it's something that we really need to do as problem solvers. How many times have you've been told when you're trying to solve a problem, you can't? You know, it's the old MC Hammer. Again, I'm dating myself back. Is that the 80s, I guess? MC Hammer had a song says, you can't touch this, right? And how many times have you been told you can't do that? Okay, you can't. And, you know, that is a 4-letter word, and it's a bad word when it comes to continuous improvement, that you can't do this. And I'm going to give you some examples of third-party examples, and I'm also going to give you personal examples that I went through in my career, that when you challenge the status quo, you really hold people's feet to the fire and ask, you know, is that really true? You really can't do that, right? Now, normally, you know, you're going to get the following reasons, and there's probably 100 more, but I'll just give you the classic ones that I always hear. You can't do that because of regulations, whether the government regulations or some other ordinance or whatever the case may be. You can't do that because the customer won't let us. You can't do that because of our specs. You can't do that because of supplier guidelines. You know, for example, I see this a lot with things like Loctite, you know, the glue. Oh no, Loctite has a specification. We can't break that specification. Okay. Industry standards, right? These are all ones that I've been involved in over the course of time. And, you know, you just can't do this. You just can't make that change or, you know, make that improvement because of X, Y, and Z. Well, let's talk about some examples, okay? Because I think as problem solvers, you have to challenge everything. I don't care what it is, you have to challenge everything. And probably the best question you can ask as a continuous improvement professional is why, right? Remember, we have the 5 whys. But you have to ask that question, why? Why is it like that? Why, and why? And you keep asking until you get down to the real essence of this. Now, I'm not saying some of these regulations and standards and specs you can violate them all just because I'm sitting here saying you can. Some you can't, right? And you've got to look at these in the context of safety, quality, delivery, and cost in that order, that hierarchy, right? I talked about that earlier on one of the previous episodes. By the way, if you're keeping track, this is episode 23. I don't know if I mentioned that earlier on. So anyway, so let's talk about a couple of things. I was working early in my Lean Horizons career. I had a company. I'm in Arizona right now. It's where I live. I'm in Scottsdale, but I was out here in Arizona at a defense contractor. They made military weapons, and we were going to take a batch and queue operation and put it into a one piece flow type scenario with standard work, cell design, all the things that you probably are familiar with. And they said, well, you can't really do that. I said, well, why not? Well, we need the government auditor's approval to even move a table. Really? You can't even move a table. Nope. We need approval for everything. I said, well, did the government auditor approve what you got out there now? Because believe me, it was a mess. Oh yeah, yeah, yeah. She approved it and blah 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 blah. Is she local? Yeah, she's local. Okay. Give me her phone number. So I called her up. He said, by the way, next week or whenever it was, 2 weeks from now, we're going to be running a Kaizen event to reconfigure the XYZ cell and put it into one piece flow, improve quality, improve delivery, improve safety, of course, as always, number one. Would you be interested in coming out and learning? And I explained who I was and, what lean was all about because I wasn't sure she really knew. And she knew a little bit about it, but not much. Would you come out and participate with us on the Kaizen? We'd love to get your input and expertise. Oh boy, I would really love that. So she came out, right? And we put her on the Kaizen team, put her, through training. We usually do 20% training and 80% hands-on. And we had goals and objectives, and it was an unbelievable success. I mean, floor space reductions, inventory reductions, quality, productivity. I mean, all the metrics went north in an unbelievable way. And she was the one coming back saying, hey, why don't we do this? Why don't we put that over there? And why are we doing this? And we shouldn't have to do that. I'll sign off on that. So we got her involved in the process. Okay. Had we gone ahead and done it and then brought her in for approval, it definitely would not have gone that well. Okay. Now, I'm not saying you could do this for everything. Right. And in some cases, you might be able to do this. I just want to give you an example where I just challenged the status quo that when they said we can't do this, I pushed back and said, no, I think we can if she's agreeable and we get her involved in the process. And by the way, I talk about solving problems at the lowest level in another episode of problem solving. And, getting people involved is one of the best ways to get their buy-in. Okay. If you instill something or enforce something on somebody, you're going to have pushing a rope uphill, as they say, right? Um, so that was just one example. Okay. But let me give you a couple other examples. Well, first of all, you probably have seen a lot of bottleneck operations where a part would have to leave a cell and go to what we would call a curtain effect, so that the operator can complete a one-piece flow operation. So, for example, these kind of operations might be, for electronic, products, a burn-in. We have to burn in the PC boards, or curing if it has to dry, if it's epoxy or paint or whatever, or heat treat or whatever, right? So, for some reason, when I ask things like, how long does the burn in have to happen? I get answers like this: 24 hours, 16 hours, 8 hours. They're always divisible, it seems, by 8. And I'm like, well, wow, that's amazing how all these technical engineering standards all come out to be divisible evenly by 8. Well, okay, I think you probably got this already, that 8 is obviously usually what a standard shift is. So they just say, okay, let's just put it there for a shift and we'll take care of it on second shift or first shift or whatever it may be, right? Well, in the process, then you're building inventory. You're over processing most likely. You are exposing yourself to greater quality fallout because the batch is bigger, the curtain effect is bigger, right? And look, I'm not saying that there's no merit to any of these numbers, but they got to be challenged. And I'll tell you right now, I would probably say 90% of the time when I challenge something like this, we brought these things down drastically. And, like Deming said, in God we trust, all others bring data. Show me the data. Show me the fallout after 2 hours, after 4 hours, after six, after eight, whatever it may be. So keep an eye on that as you guys are looking at these type of, batch processes, curing ovens, burn-ins, testing, calibration. They're usually in some semblance of 8 hours, and that should be a red flag to you to challenge those things, okay? Because a lot of times these are just at the convenience of the operations, and probably those standards have been in place for 20 years and nobody ever challenged them, right? So that's one thing. So let me get some more specific examples. Now, I'll stay on the theme right now of cure time, and I'll move into some other things in a minute. We had a plant at Danaher called Delta Truck Boxes, and we just acquired the business. And I was down there with then President Tom Joyce, who became CEO of Danaher, a good friend of mine and great guy. And Tom and I were walking around this blow molded facility. They made the big blow molded truck boxes that went in the back of pickup trucks. And they also made steel at another plant and aluminum, but this was the blow molding plant. And so Tom and I first walked into this facility for the first time. Actually, it wasn't the first time because we did due diligence there, but we walked in to now look at it and say, well, what are we going to do with this facility? And as we're walking around, there were piles and piles of truck boxes all over the place. And we're walking with the VP of operations. And I asked the question, I said, well, why are all these boxes here? And the first thing he did was he held out his hand to me and he said, you got to understand blow molding. Okay, tell me about blow molding. Okay, which I did have some familiarity with, but tell me about blow molding. Tell me what I don't know. Why all these boxes are here, all piled up, 5 high. Well, when they come off the blow molder, we can't assemble them right away. We have to cut out the top, and we can't assemble them because they'll warp. So they have to cure. Now, the first thing that's going through my mind is, okay, you're taking hot boxes and piling them on top of other hot boxes and all that weight. Okay, you get the idea, right? But I didn't say anything. I said, okay. I said, well, how long do they have to cure? And he said, they have to cure for 48 hours. Oh, okay. There you go. Divisible by 8, right? So again, red flags went off. It's a second red flag. The first red flag was, look at all this inventory. So I said, well, let me ask you. I said, is that like your standard? Is that you got to study on that? Yeah. We through experience we learned that this is the right number. Okay. I said, well, can it be 47 hours? And he looked at me and he said, yeah, I don't see why not. Okay. I said, how about 46? He shook his head. 45? Look, I'm going to keep going until you tell me to stop. Okay. And I said, you really don't know, do you? Okay. Show me the standard, right? That you came up with the 48 hours. Well, he didn't have one. By the way, on the previous podcast on problem solving, I talked about standards. Okay. So this is a type 0 standard. There was no standard that exists. Okay. If you go back to that previous podcast, you'll find out that this is a type 0 problem. No standard exists, but it was the practice. Okay. So I guess in some sense, you can argue it's a very loose standard, but it's not really a standard. So I said, look, guys, I said, and he has engineers and his plant guy with him and all that. So I said, why don't you guys go back and take a look at this? Get your quality guys and your engineers and do some experiments. And let's find out how long it really needs to cure. how about we come back on Thursday and we'll have a meeting, 10 o'clock in the morning, and we'll talk about what you found out. He said, okay, fine. So we continued our tour and did some other things that week. And on Thursday, we came back and he they did a big PowerPoint presentation, which I could have killed him on because it's I don't want a PowerPoint presentation. Lean by PowerPoint, right? It's what a lot of big consulting firms do. We want to just know what you found out. So they said, Mark, you were absolutely right. It does not need to be 48 hours. It only needs to be 20 minutes. 20 minutes, not 48 hours, not 20 hours, for 20 minutes. So long story short, we said I shut the plant down for 3 weeks. So the quality problems we had to do. There was a lot more than 48 hours worth of inventory. We fixed some quality problems, create one-piece flow cells with standard work in process for curing, takt time of 2 minutes. So we needed, with 20 minutes, we needed 10 units, or 20. How's that work? 2 minutes of takt time. Yeah, we needed 10 units of standard work on a first in, first out basis in our curtain, and continued a one-piece flow right at the machine. Because what the operator was doing was standing there watching the machine run for 2 minutes. So we got him involved in the assembly and also the packing. We packed everything right there. The packing was on the other side of the shop. We freed up probably, I don't know, 60% of the floor space just because of the inventory. So here's a case where you just challenge the status quo. Now, what I found out was there was a quality problem 10 years ago with a customer, and the plant manager at the time, who wasn't even there anymore, instituted this 48-hour thing. This 48-hour, I hate to call it standard, but it's a standard. And nobody challenged it for 10 years. It's just what they did. And so, creating that culture where we challenge ourselves all the time. Why are we doing this? Because a lot of people come to work, they don't mean harm, and they'll come in and they'll check all the boxes and do all the things that are supposed to happen, but not really give a lot of critical thought about why they're doing what they're doing and how that affects not only the customer and quality and all that, but how it also affects profitability and all that stuff, right? So this is where you have to think like a business person before you think like a lean zealot. And so many people out there in this space today just think like lean zealots, and they can't communicate with somebody who's being measured on making money. And that would be a whole nother episode, by the way. Sort of deviated there. Okay, so that's the blow molding example. Okay, let me give you another one. This happens to be something I heard from a friend that used to work at a large aircraft manufacturer, and I won't mention who it is, but you could probably guess, right? And they actually had the Japanese in there. They had Shingijutsu in there, and I don't recall which consultant it was, but the consultant wanted to put the fuselage of, it might have been a 737, one of those planes. It doesn't really matter, on a flow line, and he wanted to have a moving line, okay, and time it all to takt time and all that stuff. And by the way, Nakao, my sensei that I talk about, Nakao, and I will do a podcast on Chihiro Nakao down the line because he's such a special person and a big mentor to me. But anyway, Nakao showed me a one-piece flow line for a aircraft engine, and the takt time was about 2 days, and it moved ever so slowly. And I've gotten into some arguments with people that used to work at aircraft engine companies, but you can't put it in a flow line because blah 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 blah, and it moves too slow, the takt time's too long, and that is bull. And maybe I'll have a whole episode on that someday because I proved that to this individual he was wrong, and that that a flow line, even with a very slow takt time, long takt time, still makes sense. Okay, because you just can't time the labor to takt time by having stationary squares on the floor and all that. Maybe someday I'll do a podcast on that. But anyway, so the engineers were telling this Japanese consultant, we can't move this fuselage. It's too freaking heavy. So he says, give me a hand drill, a battery operated, I think he said it was a DeWalt hand drill made by Black & Decker. battery operated. He tied a cord to the chuck. He tied the other end of the cord to the airplane, and he stood there and pushed the power button on the drill, the power drill, and the chuck started moving, and the cord started wrapping around the chuck, and the airplane started moving. Okay. So do you see what I'm saying here? When somebody says something like, "We can't move that airplane," everybody, 99% of the people are going to say, "Yeah, he's right, man. You know how heavy that thing is." Not to think that a little golf cart on the airport is moving a whole airplane with the engines and everything. Okay. And but this is just the mindset that we get into, where we're so schooled at trying to understand, at looking at why we can't do things, that it gets in the way of the things we can do. It's a mindset. It's so easy to find out all the reasons why something won't work, as opposed to looking at, well, how can it work? Right. And sometimes you have to reinvent yourself to be able to do that. Now, the last one I'm going to talk to you about was a client of mine that makes these small parts, and they have to go through a washing operation. Okay. Now, it's a foreign company, and the washing operation starts out with raw water, and the operation needs RO, okay, reverse osmosis water. So they were under pressure by the local by the government to reduce their water consumption, or they would have shut the plant down. All right, they were consuming too many liters of water per day. Blah 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 blah. And this is the operation that really consumed most of the water. So the parts had to go through a 5-stage process. There were 5 barrels that the parts had to go in. So, process 1, process 2, process 3, and all that. And all of them were, the water that they put into each one of these 5 processes were RO water, which again, right up front, you're losing, 40% of your water just by converting it over. So I asked the question, well, how much water does each tank need to have? And they told me it was 60 liters. I said, okay. Can you show me the spec? They couldn't find it. They couldn't find the spec. Again, like the truck box thing, the blow molding, they were based on tribal knowledge. It's six. They looked at, and they were making parts for the automotive industry and also aerospace. So they looked at all the specs as it related to this process, and they could not find any spec that dictated 60 liters. So I said, okay, let's do a mini design of experiments here and go figure out what the number needs to be. And when they came back, they said it only needs to be 30. I could have still challenged that, but I didn't. I said, okay, well, that's a 50% reduction. All right, maybe some other day we'll fight that battle, because there were other battles we needed to fight. And the reason they were using RO water, because the raw water would have rusted the part. RO would not, for some reason. There was other chemicals involved in all that. So then I said, well, why does it have to go through 5 stages? Well, because, and nobody knew. Nobody knew. Okay. Why does it have to go through 5 barrels? You take the parts in one barrel, put it in another barrel. Okay. And I challenged that. Show me the spec. Show me, like, look, I'm trusting you guys, but I want you to verify. Trust but verify. Okay. Challenge the status quo. That's the title of this episode. And they came back and they did some more experiments and found out they only needs to go through 3. So we got it down to 3 now. And again, I still could have persisted and challenged a bit more, but I didn't. I said, okay, let's go from there, right? In some cases, you have to allow them to save face too, right? And then I said, well, why does the first process and second process need RO water if since these are going one at a time, in and out, isn't it the last process that only needs RO water? They went and did more experiments. They never spec on that either. And sure enough, it was only the last process that needed RO treated water. So we reduced the water consumption by, I don't know what the number was, 70%, whatever. We got them well under the spec of what the government was mandating over there. So again, could I gotten hung up on one more, reduction, like why not 2 barrels? Why not 15 liters of water? Why not, or there's an alternative and all that. In the world of continuous improvement, you've got to know when to stop, okay, and then pick that up some other day. I could have burned a lot of calories on going from 3 barrels to two, and miss all these other opportunities. So you have to kind of think about what really is best uh, for the overall objective in terms of what we're trying to do. Because darn well whatever we did that day or that week would not have been perfect, and we would of course have to come back later. But you don't want to go down a rabbit hole. You have to kind of say, okay, that's great. You got down to 3 barrels, you got down to 30 liters, and you'd only do an RO in one. That was a big win. Okay. One of the things I talk to leaders about is going into a Kaizen review and then saying, hey, how come you guys didn't go to 2 barrels? And how come you didn't do this? And how come you do that? And my comment to them would be, and this is a coaching that we give, you've been here how long? 15 years? And all of a sudden you come up with this brilliant idea and these brilliant questions? No, you can't ask those. Sorry. You weren't on the Kaizen team. Okay. You're not allowed to ask those questions. I don't care if you're the CEO or not. Okay. Because you were here for 15 years and didn't see an opportunity here. And now you're challenging this team. Because what a Kaizen does is it opens up doors for you to be able to see the next steps, right? To penalize the team and actually make them feel foolish that, they missed an opportunity they didn't think and all that. Well, they're the ones that got you to where you are right now. Let's celebrate that. And we know every standard's imperfect, and whatever we come up with will be subject to Kaizen, because whatever we know that whatever we do today can be done better tomorrow. So I developed a saying that Danaher called uh, uh, with the status quo, healthy dissatisfaction with the status quo. Kaizen is a healthy dissatisfaction with the status quo. So you can't beat yourself up all the time. You got to celebrate. So on Friday, let's celebrate because we did some really great things. And we come back on Monday, let's get a little bit angry and find out how we can do better in a healthy way. Okay. Otherwise, it's all negative, and that's not good. Right. So anyway, I just want you to know that when you do problem solving, do not accept anything that somebody tells you. I don't care who they are. Ask for data. Ask for evidence. And if you don't know, go out and find out. Like we did with the blow molding, like we did with the water reduction and things like that. Okay, so I would probably say that a good 80-90% of the time that I challenge these type of paradigms, they were in there for convenience. They weren't in there for driving efficiency and delivery and quality and all that stuff. In some cases, safety, right? So I'd be interested to know your stories about your company and how you challenge the status quo, and what kind of pushback do you get? Because I'm sure you do get some pushback, and that's okay. It's natural. You're going to get the old, well, you don't understand blank, 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 and you're not an engineer, or you don't have. I've got 20 years of experience here with this. How could you say that? I've had that thrown at me all the time, and in some cases those are valid points, but most of the time they're just defenses that need to be challenged. So remember the trust but verify from Ronald Reagan: trust but verify, and challenge the status quo. Okay. Anyway, this was episode 23. I'd be interested in your comments at send me an email at Mark, M-A-R-K, Mark at lean911.com. All of these episodes can be found on the website lean911.com, and also you can find them on Apple Podcasts, and also this video that I'm recording is if you want to see my pretty face is on the on YouTube. And so anyway, look forward to hearing from you on this matter, and I'm sure you've got all kinds of experiences in this regard, and we will see you next time. Okay, stay lean, and we'll talk to you soon. Bye-bye. Thanks for listening to the Lean 911 podcast. I'll be happy to address your questions or feedback on future episodes. Email me at mark@lean911.com. You can check out our other episodes by visiting our website at lean911.com, our YouTube channel, wherever you listen to podcasts. This is your host, Mark DeLuzio. Thanks for listening.